Lesson 4.6 is about correlations. Correlations are trends that we see. This we use a lot in real life because nothing fits perfectly in life. Okay, I can't say nothing. Most things don't fit perfectly to an equation in life. So we graph as many points as we have, and then we decide if one thing is making a difference in the other. Okay, I can't say that it's causing because causing and correlation are two different things. But if there's a correlation, they might be two related items. Okay, so looking at this first scatter plot, could I draw a line in there that would be close to most of the points? No, they're scattered all over the place. So there is relatively no correlation between whatever this graph is talking about, whatever two items this graph is talking about. Okay, the second one. Okay, if I were to draw a line somewhere in there, okay, I would probably draw it through there. Okay, is my slope of that line of best fit positive or negative? Okay, well, if I start here, I'd be counting up and forward, so that's a positive slope. So it's a positive correlation. So as these values are going up, these values are also going up. Okay, and the third one, if I were to draw my line of fit, these ones don't fit as well as the last one, but that's still pretty close to most of the dots. Okay, to count my slope, I'd be counting down and forward, so that would be a negative slope. Okay, so as the x values are getting bigger, the y values are doing the opposite. They are getting negative. Okay, we want to make a scatter plot of the data and draw a line of fit. Write an equation for the line. So first thing we got to do is graph all the points. -2, 4, -1, 2, 0, 1, 1, -2, 2, -1, and 3, -2. Okay, so I want to draw my line of fit through as many of the points as possible. Okay, do you see how these ones all are in a line? And then there's one that's not on the line above and one that's not on the line below the line. Okay, that even creates balance between the points that are not on the line. So that's a very good line of best fit for the scatter plot. Now we need to write an equation. What do we need to write an equation? We need at least one point and a slope. So let's find a slope. So I pick two of the points that lie on my line. I could pick any of those four. I'm going to pick these two. Down 1, 2. Forward 1, 2. Okay, so I have down, oh my goodness, down 2, forward 2. So -2 over 2, which is -1. Okay, my slope is -1. And then I need one of my points or my y-intercept. Do I know my y-intercept? Yeah, we do. It's right here at 1. So y equals -1x plus 1. Okay. starting the same thing, negative 3, 1, negative 2, negative 1, 0, wait, negative 1, 0, 0, negative 2, 1, negative 4, 2, negative 5. Okay. Well, this one's a little harder to fit that line of best fit. So I see that these 3 points are on the same line. Okay, these 2 are on that side and this one is on this side. So it's not balanced, but I still got 3 of the 6 points, so that's pretty good. Now, writing my equation, I need my slope. Down 1, 2, down 2, forward 1. Okay, so negative 2 over 1, which is negative 2. Okay, and do I know my y-intercept? Hey, look at that. I know it on this one too. It's at negative 2. Okay, so y equals negative 2x minus 2. Okay, try the last one on your own. Try the last one on your own. 0, negative 3, 4, negative 2, 3, 0, 2, negative 1, 1, 1, 0, 1. Ugh, that's all over the place. What did the directions say? Oops, wrong page. Make a scatter plot, draw a line of fit, write an equation. Okay. Well, I guess it didn't say if possible. So, aren't these 3 on the line? On the same line? That's 3 out of 6. They're a lot more spread out than that one. Okay. It's still an okay fit. Slope, 1, 2, 1, 2. 2 over 2 is 1, so slope is 1. Y-intercept is negative 3. Y equals 1x minus 3. Okay. Make a scatter plot of the data. Describe the correlation of the data. If possible, fit a line to the data and write an equation of the line. Yay, now it's if possible. So if we have a split kind of like that, we can decide that it doesn't fit or it's no correlation. Okay. Negative 2, negative 4, negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, 0, 1, 2, and 2, 1. Wow, look at that. One on top, one on bottom. It's nice and balanced. Okay, is my slope positive or negative? Well, it's up 1, forward 1, 1 over 1, which is 1. So m equals 1, which is positive, so it is a positive correlation. Did I just spell correlation wrong? I totally did. Oops. And do I know my y-intercept? Yep, it's negative 1. Y equals 1x minus 1. One of these times we are going to run out of luck with that y-intercept. I know it. Okay, let's try this one. Negative 4, 7. Negative 3, 5. Negative 2, 6. Negative 2, 3. Negative 1, 4. 0, 2. 1, 1. this is a hard one because I could put these three on the same line or these three on the same line. If I put these three on the same line, then I'd have one above and three below. Or it looks like I might be able to put maybe those three on the same line, maybe. Down 1, 2, 3, 4, 5. 1, 2, 3, 4. Nope, they are not on the same line. Well, even this way, there's three above that are pretty close to the line and two below that are pretty close to the same line. Okay, so slope m equals negative, oh, what did I say it was? Negative 1, 2, 3, 4, 5, down 5, forward 1, 2, 3, 4, 5/4. Okay, so that's a negative correlation. I remembered how to spell it this time. And our y-intercept, we got lucky again. Y equals negative 5/4 x plus 2. Okay. Thermostat. The table shows a thermostat setting in units called gas marks on a British gas oven. The corresponding temperature in degrees Celsius. Okay. So the setting, the gas mark, and the temperature in degrees Celsius. Okay, make a scatter plot of the data where X represents the thermostat setting in gas marks and Y represents the temperature in degrees Celsius. Okay, so we graph it. 2, 150, 3, 160, 4, 180, 5, 190, 6, 200, 7, 220, 8, 230. If it were up to me, I would have changed this graph some. Okay, it's kind of hard to tell that those aren't even a straight line, but I know they're not. So I'm going to pick let's go with the first point and the last point. First point and the last point. Okay. We made a scatter plot. Done. Describe the correlation of the data. Well, my line looks to have a positive slope. And it makes sense that if you turn the thermostat up, the temperature would rise. So positive, as one goes up, the other goes up, okay? An oven set to gas mark 10 heats to a temperature of 260. Does this fit the trend shown by your scatter plot? Explain your reasoning. Well, first off, I'm going to find a equation for my line. And I'm going to do that using the 2 points that I decided were definitely on my line by finding slope, y2 minus y1 over x2 minus x1. So 230 minus 150, 8 minus 2. Well, 8 minus 2 is 6. 23 minus 15 is 8. Am I right? Yep. Okay. Can we simplify 8/6 by 2? Okay. Divide by 2, divide by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. Okay, so y equals 4/3 x. Oh, I knew we'd run out of luck with the y-intercept. So let's just put it in point slope form. X minus x1. Okay, now I need a point. So I'll pick the point, one of the points that I said was on my line, the 2, 150. So y minus 150 equals 4/3 times x minus 2. Okay, got it. I have an equation. Now I want to check to see if this point is on the line. How am I going to do that? Well, we're going to plug it in and see if it makes a true statement. So 260 in for the temperature y, okay? So 150 equals 4/3 times 10 minus 2. Okay, 10 minus 2 is 8 times 4/3, 260 minus 150. Whoa, how did my third become a 4? Or 1. 8 times 4 is 32. 3 times 1 is 3. 260 minus 150 is 110. Okay, 32 divided by 3 is going to be a little bit less than 11. Oh, wait. Dang it. Who is telling me that I was wrong? Oh, I didn't even have to show you guys that I was wrong, but I did. I was wrong again. Okay, 32 divided by 3 is a little less than 11. So 11 is pretty close to 10 point, whatever this is going to be. So does this fit the trend? It's pretty close to fitting the trend. It's pretty close to right. Okay. Again, the line we drew is just the best fit that we chose. So if I had chosen my line a little bit differently, it probably would have fit better. Okay. Bring your questions to class.